Hey everyone, welcome back. This is Maddie. Let us continue our session with Java data types. Data types in Java tells what kind of value a variable can store and how much memory it needs. For an instance, let's take in your room you have a wardrobe with different compartments and with different sizes that are intentionally made for different types of clothes and different size of clothes. It goes the same way how we use data types in Java. We have mainly two categories of data types. One is primitive data type and the other is non-primitive data type. Within primitive data type, we have 8 types. Let us look into 8 types of primitive data types first and then we'll go to non-primitive data types. The first non-primitive data type we have is byte, which is used to store very small whole numbers, and the size it can take is 1 byte, that is 8 bits, and the range could be negative 128 to positive 127. And in Java, byte is used mainly when memory saving is important, but nowadays memory is not costly. Example of byte could be temperature reading and age of a person. The second primitive data type we have is short. Short data type stores small whole numbers but larger than byte. Size of it could be 2 bytes, that is 16 bits, and the range it can take is from negative 32768 to positive 32767. Short data type is rarely used, but it's good to know. Example of it could be school roll number and a small village population count. The next primitive data type is integer data type, which is mostly used data type in Java. It stores whole numbers. Size it can take is up to 4 bytes, that is 32 bits, and the range is from negative 2 billion to positive 2 billion, and this range is enough for most of the use cases. Integer data type is the default choice for numbers. Example of it could be a salary of a person or age of a person, marks of a student, and it goes on. Our fourth data type is long, which is used to store very large whole numbers. Size it can hold up to 8 bytes, that is 64 bits. And whenever we declare a long variable in Java, we will always end with a capital letter L. Long data type is used when integer range or size is not enough. Example of it could be a phone number, population of a country, bank account number, and so on. Fifth primitive data type is float, which is used to store decimal numbers with less precisions. Size it can hold up to 4 bytes, that is 32 bits. And same like long, whenever we declare a float variable in Java, we will always end with small letter f. This data type is used when small decimal precision is enough. Like an example, product of a price. And whenever we take height and weight values, where we store very less decimal precisions. Next data type we have is double, which stores the decimal numbers with more number of precisions. Size of it could be 8 bytes, that is 64 bits. In Java, whenever we want to store a decimal numbers, double data type is the default choice. Example of it could be a GST percentile or a bank balance and so on. Seventh data type we have in primitive is char, which is used to store single character. Only one character is stored, not a word. Size it can take up to 2 bytes, that is 16 bits. Characters are stored in Unicode. For example, a small letter A is stored as integer value 64. 64 is the Unicode of small letter A. Example of char data type could be a class grade like A, B, C, or answers choice like yes or no. The last primitive data type we have is Boolean, which stores true or false. Size of Boolean data type depends on the JVM, but conceptually it takes 1 bit. Example of Boolean data type could be is active, whether the person is active or not, whether the student is passed in exam or not, and so on. Here in primitive data types, you don't need to memorize ranges for now. Understanding the usage is more important. Let us move on to non-primitive data types. Non-primitive data types are used to store multiple values, complex data, or a collection of data instead of just one simple value. They are also called as reference data types. Let us look into non-primitive data types one by one. The first one we have is string, which is very important in Java. String is used to store text with multiple characters instead of a single character. And in Java, whenever we declare a string data type, we will always write the value of a variable within double quotes. Example of it could be your name, city you live in, email ID, and so on. Next non-primitive data type is array. An array is used to store multiple values of same data types. It is kind of a multiple blocks of same size and type, which are intentionally made to store same type of items. Example of it could be student marks, products prices, and so on. Third and fourth data type we have is classes and objects. Class is nothing but a blueprint used to create object. It is same as a civil engineer creating a blueprint of a building before building it, whereas the building is the object, the blueprint of building is the class. An example of classes and objects could be, let's take we have a class student and an object Maddie, who is one of the students of a class student. Each object can have its own behavior and its own properties. And the last non-primitive data type is interface. An interface just defines what a class should do but not how. An interface is used heavily in real-world project APIs and frameworks. Now we'll be looking into each data type with the sample programs. Now let us declare each of the primitive data types and print them out on the console just to see how they look. First we have is byte B. Next we have short. I'll just give year part of date. Then integer I. Just give the salary of a person. Next long L, which takes in the phone number. Next float F, GST percentile. If we don't give the small letter F next to the value, it will throw an error. Next we have double, which takes more precision numbers. Next character. The last primitive data type is Boolean, which takes in either true or false. Now let us try to print all of them. Next float value, next decimal value, next character. Now let me run the program. It just printed out all the values. Now let us discuss two important concepts. The first one is typecasting in Java. Typecasting is nothing but converting one data type into another. We have mainly two types. The first one is widening casting, and the second one is narrowing casting. Before we talk about typecasting, let us see the hierarchy of data type. First we have byte, and then comes short, then int, then long, then float, the last one double. Let us see what is widening casting. It is nothing but converting a small data type to big data type. Consider we want to convert integer data type to double. Let us see that with an example. I'll just declare a integer variable num with the value 10, and if I want to convert it to double, I can directly assign a integer variable to a double variable, and Java takes care of widening casting in the background, and it is automatic since we are casting the data type in the order. Whereas in narrowing casting, we will convert a big data type to small, and it won't happen automatically. Here in case of widening casting, whenever we convert the data, we won't be losing any data, but in case of narrowing casting, there may be a loss in data. Let us see that with an example. I'll just declare double x with 10.99, and if I want to convert it to integer, I need to manually typecast it to integer and then the double variable. Now if I try to print y, I'll just be getting only 10 but not the 99. I'll be losing this 0.99 data. Let us try to run it. Before running, let me print d1 as well. See, since we are converting an integer to double, it is just appending the decimal precision. Whereas in case of narrowing casting, even though we have a decimal precision, but we are losing the data here in case of narrowing casting. So that's all about typecasting in Java. And the second important topic is overflow and underflow. What are overflow and underflow? When a variable exceeds its range, it wraps around. Let us see them with an example. Firstly, we'll take overflow. I'll declare a byte a with 127, and now if I try to increment it, it will just wraps around it to minus 128. Since the maximum range of byte is 127, if I try to increment above 127, it wraps around to minus 128. Let us try to print a and check. It should output minus 128. Yes, it is wrapping around itself. The next we have is underflow. I'll just declare the same byte with minus 128, and if I try to decrement it more, it will just wraps around itself and takes the value of 127. Let us try to run it. Yes, it is wrapping around itself and taking the large range of byte. That's all about primitive data types. We have discussed the 8 types of primitive data types: widening casting and narrow casting, and then overflow and underflow. Now let us see the examples of non-primitive data types. The first non-primitive data type is string. Let me declare a string variable name with the value Maddie. I'll just print it out on the console. And in string class, we also have a special methods where we can access character at particular index, we can get the length of string and so on. That's the beauty of string and array classes. Let me access the third character of name. So we have a method called caret, and then let me try to print the length of string. We also have few other methods. Just play around with these things, two lowercase, two uppercase, where they convert all the characters of string to lowercase or to uppercase, and play around with these methods, built-in methods. You will understand it very easily. Let me run this. Yes, it's just printing string name, and then caret 2 is Maddie, and then name dot length 5, and the string length is 5. You just create a class and play around with these built-in methods. You will understand them easily. The next data type we have is arrays. We are just declaring an integer array 12, 17, 18, 25, and so on. There's the syntax to declare integer array, and we can't directly print the array numbers directly. Instead, it will print the memory address of array. I'll just run the program. You'll see it practically. So it's just printing the address of an array variable ARR. Then how we can access it? Using a for loop. These for loop, if conditions, while loop, all those things we'll be discussing in the next coming video. For now, like, you just understand how we can declare array and few built-in methods. Let me show a few built-in methods. We have a built-in method called length, where it will print the length of array, and we can also access a value at particular index. Let me try to print again the second number in the array. Array.length is 4 and the second element in the array is 18. That's about string and arrays. And other non-primitive data types were classes, objects, and interfaces. All these things you will be learning in detail in OOP concept. We will discuss all of this in detail later on. That's it for this video. See you in the next video.